Good day everyone. I am Anika Chantal Bautista and I am here to discuss about the bond dissociation energy or BDE. So, bond dissociation energy po is all about the energy required to break a chemical or covalent bond. So, since energy po yung kailangan natin, it is typically denoted po or we use the kilojoules per mole or kilocalories per mole. So, having a high BDE po, meaning it has a strong bond. Meanwhile, having a low BDE naman means has a weak bond. So, we have factors po that affects the bond dissociation energy. So, first po is we have the bond order. Sa bond order po, having a higher bond order means it is also has a higher BDE and stronger. So, sa example po natin dito is we have the triple bond. So, since tatlo po ang bond niya, it is stronger po than the double bond. And the double bond, since dalawa po ang kanyang bond, it is stronger than the single bond. So, this is because po multiple bonds share more electrons and stronger interaction between the atoms. So, next po is we have the electronegativity. So, parang same lang din po siya. Having a higher electronegativity means also has a greater BDE. So, sa bond length naman po, having a shorter bond length, it is stronger. Meanwhile, kabaliktaran, longer po means weaker. So, sa atomic size naman po tayo. Sa atomic size po, having a smaller atom means it is stronger. And having a larger atom means it is weaker po. And we have the resonance. So, bonds in resonance structures po may be delocalized. So, it may influence the strength ng ating BDE. And lastly po, add ko lang po ang isang factor po na nakaka-affect is yung polar covalent bond, it is stronger po than pure covalent bond. So, next po is we have the BDE and reaction enthalpy. So, here naman po is we can use po the BDE values to estimate the enthalpy change for a reaction. So, here po is we have the formula. So, enthalpy equals the sum of bond energies of bonds broken. This is a reactant po. Minus the sum of bond energies of bonds formed, which is the product. Ayan. So, if the result is a positive enthalpy, it means po na it is an endothermic reaction and the energy is absorbed. Meanwhile, having a negative enthalpy naman po, meaning it is an exothermic reaction and the energy is released.
Okay, hello po. I'm Levetta Justin, and since now that we have learned the idea or the concept of bond dissociation energy, we will now proceed to the examples. Okay, so now we will proceed to the example. So given to the example, a hydrogen gas. So this two hydrogen reacts with the chlorine gas. So two chlorine to produce hydrochloric acid. So produce hydrochloric. So there you go. So we're gonna have to estimate the enthalpy of formation of one molecule of hydrochloric acid using the average bond dissociation energy based on the given listed below. Okay, so before we proceed, we should understand first the formula. So the formula is the enthalpy will be equal to all of the sum of all the reactants minus the sum of all the product. So you may ask, bakit positive yung reactants while yung product is negative? So as we have learned earlier from the definition of bond dissociation energy, in order for the bond of an element of an atom to another element of an atom, we need to put off a outside energy. So that outside energy can either be UV light, any source of heat. So we insert heat. So that is what we call as endothermic reaction. So when we put up heat, we will be able to broken down the bond between those two atoms of an element. So that would be. Now, in order for this bonded element of an atom, we have to release the energy in order for the two atoms to be recombined or bonded again together. So that's why when we exert the heat, when we release the heat, we will be able to recombine the bond between element of an atom to another element of an atom. So that is what we call as exothermic reaction. So if it's an exothermic reaction, then the enthalpy of reaction is negative because you release energy. While dun sa pag didisbanded ng dalawang bond between those atoms, we put up an outside heat, which is an endothermic reaction. So endo meaning inside. So we insert. So thermic, so comes from its root word, that temperature. So endo, so the enthalpy of the reaction will be positive. So that's why the formula is like this. Yeah. Okay, so with that idea, we will now proceed to the example. So what we have, so what we have here is a hydrogen gas, a chlorine gas, which produces an hydrochloric acid. So given dun sa example, we need to get the formation of 1 mole lang. So you may siguro naisip nyo na mag-add na, kasi as you can see here, hindi siya balanced, right? So baka iniisip nyo, if you put 2 up in front of the HCl, the equation will then be balanced, which is true. But in the example, we only have to use 1 mole of HCl, so we can just add 2 here. So this is 1. This can be only 1. So what we'll be having to do is adjust on the other side. So I'm gonna get the half of this hydrogen gas and chlorine gas. Oh, sorry. So I'm gonna put up 1/2 over here. So let me rewrite this quick. Okay, with this equation now, the equation is now balanced, right? So we have a total of 1 hydrogen, 1 chlorine gas, and 1 hydrochloric acid. So now we will have to visualize first kung ilang bond meron dito sa given below. So, we have a total of 2 hydrogen. So, we have 2 of them. Next, we have total of we have 1 bond between hydrogen and hydrogen, and we also have 1 bond of chlorine to chlorine, and the bond between hydrogen and chlorine. So now, so after finding the balance equation and the bonds between the elements, we will now proceed to continue answering it. So ito na again, ito yung formula. So enthalpy of the reaction is equals to all of the sum of the reactants minus the sum of all the product. So we're using this formula. Wow, nakalimutan ako. So now that we get the balance equation and okay na siya, we will now proceed to the substitution. So isa-substitute lang natin yung value ng bonds na given below, given above here sa example. Okay, so the value of the bond between hydrogen and hydrogen is 4. So parenthesis, don't forget the parenthesis. Hydrogen is 427 kilojoules per mole plus the so the bond between chlorine and chlorine is 239 kilojoules per mole, and last so kilojoules per mole. And so for the hydrogen and chlorine, just the product, yung arrow pala, sorry, magiging minus na siya. So be hydrogen, chlorine, which is 437 kilojoules. Okay, sulat. $437 kilojoules per mole. Okay. So now we will just have to plug it in our calculator. So try it up, guys. So now the estimated value, nakuha natin, plug in ko lang sa calculator. Okay, so the enthalpy of the reaction is equals to negative 101.5. So that will be kilojoules per mole. So that will be the final answer. If mali man yung calculation ko, guys, pa-correct na lang po. Okay. So, anong napansin natin dito? So, ayan, negative yung final answer. So, that means that we exert heat. So, the energy is released. So, that this is an exothermic reaction. So, now, let's proceed sa next na example. Okay, so now we have to estimate the enthalpy of combustion of methane using the average bond association energies listed below. So what is the chemical formula of methane? So that will be, type carbon, which is bonded to 4 hydrogens. So this is the cubical structure of the methane. So we're gonna have to enthalpy of combustion. So that will look like this. So methane will look like this: CH4 plus the combustion, so oxygen. So if there's a present of combustion, ano yung magiging outcome niya? So it will release carbon dioxide and water, H2O. So again, we're gonna have to balance it out. So bilangin muna natin kung ilang elements side by side. So here we have a total number of 1 carbon and 4 hydrogen, as well as 2 oxygen. On the other side, we have total of, again, 1 carbon, only 2 oxygen, and 2 hydrogen and 3 oxygen. So unbalanced pa siya. So gonna try to plug in saan tayo mag-add first. So since mas madami dito yung oxygen, so we're gonna first have to add here. So gawin natin siyang 2. So magiging 4 na siya. 4 ng hydrogen to the side. On the other side, we're gonna plug in another 2 here sa left side ng hydrogen. So magiging 4 na din yung oxygen, right? And ayun, nasaktuhan na rin. Magiging 4 yung hydrogen. Okay. Now with the equation being balanced, we will now proceed again to compute for the enthalpy of the combustion of methane. So first, write natin yung formula. So the enthalpy of the reaction will be equal to sum of all the reactants minus the sum of all the products. Okay, so that's the formula. Okay, now we will have to again identify kung ilang bond meron. So for the methane, we have a total of 1. Okay, so we have 1 bond of carbon and hydrogen. We have 1, 2, 3, and 4. So we have a total of 4 bond between carbon and hydrogen. So we're gonna plug in 4 and the carbon and hydrogen plus. Okay, so how many oxygen? We have total of 4 oxygen. But if we draw the Lewis structure of oxygen, so we all know that the oxygen has a total of 2, 4, 6. 2, 4, 6. Am I right? 7. Okay, so ayan, the oxygen has a total of 6 valence electrons. So if they are going to combine with another oxygen, it will have to give up 2 valence electrons for pairing. So we have 4 of them, so another one here. they're gonna share again another 2 valence electrons. So that will be 2 O double bond O oxygen. Okay, so ayan. Okay, minus the bond between ayan. So again, yung pakipag-bond the oxygen is dalawa yung pinipair ng valence electron. So that would look like this. Carbon having total of 4 valence. Then for the oxygen, we have total of 6. So ganyan itsura niya. So we're gonna have, since we have a total of 2 oxygen, so that will look like this. And now for the last one, the bond between oxygen and hydrogen. So ito single bond na lang since si hydrogen only has 1 valence electron to share. So we have total of 2, so 2, that will look like this. So we have 4 oxygen here. Tama ba? No, 2. Sorry. So again, following the procedure, we will have to plug in the given value of the bond between each other. So for the bond between carbon and hydrogen, we have the value of 413 kilojoules per mole. So wag mo muna natin isulat yung for here plus oxygen. To oxygen, we have 495 kilojoules per mole again yan. Just to remind you guys, minus the sum of all the products, yung value nung bond between the carbon and then oxygen, 745. Plus natitira a bond between oxygen and hydrogen, which is 467 kilojoules. Okay, now na na-substitute na natin, we will just have to manually calculated, i-plug in na lang again sa calculator. So ayan, okay, the enthalpy of the reaction will then be equal to negative 716. Don't forget the kilojoules per mole. So that's the final answer. And again, if the final answer is negative, it determines that heat is released, an energy is released. So that's an exothermic reaction. Moving on to the next one.
Good day everyone, I am Janela Reyes and I am here in front of you to discuss that's the definition of homolytic cleavage or homolysis. So, when you hear the word homolytic, always remember na ang prefix na homo, ang meaning niya is something that always the same, and ang suffix na lytic is always break apart or split apart. So, in a simple word, ang homolytic cleavage or homolysis is isa siyang proseso kung saan ang covalent bond nagbe-break siya evenly, na kung saan din ang each atom tinitake niya yung one electron from the shared pair to form two neutral or the highly reactive free radicals. So, sa madaling salita, ang homolytic cleavage now is a break sa bond equally, meaning the two electrons in the bond are split evenly between the two atoms. And sabi dito, merong formation of radicals. So, paano nga ba nagkakaroon ng formation of radicals? So, ang nangyayari kasi, diba, yung each atom kasi kaya siya nagiging radical kasi pareha sila nakaka-receive ng unpaired electron. Example, pag-expose siya sa UV light, heat, or non-polar, ang nangyayari, yung bond nagbe-break siya evenly and each atom nakaka-receive siya ng electron.
Hello everyone, I am Lloyd Michaelo A. Romea, and now I'll be explaining to you the examples of the homolytic cleavage. As you can see here, chlorine 2 turns into 2 chlorine radicals. So, yung chlorine 2 po, if it's under the heat, UV light, or non-polar environment, or high energy source, mangyayari po yung homolytic cleavage. So, magbe-break po siya evenly. So, heat gives the energy needed to break the bond equally between two chlorine atoms. So, each chlorine atom takes one electron to form two chlorine radicals. So, ang ganito po yung na-visualize ko dyan. Ito po yung bond nila. Ito yung chlorine, ito yung chlorine. Ito po yung bond nila, connected sila. Tapos, under po ng heat, UV light, non-polar environment, or high energy source, kahit alin po doon, ay magbe-break sila easily. Tapos, magiging radicals po sila. Tapos, makakakuha po sila ng 1 electron. So, yun po. Similarly po sa ating second example, CH3 to CH3 turns into CH3 radical plus radical CH3. So, the carbon-carbon bond splits under the UV light. Kita po natin dito, under the UV light. So, it splits under the UV light to form two methyl radicals. So, naging methyl radicals po siya after ng homolytic cleavage. So, yun nga po, ang conditions po niya or kung kailan po siya nangyayari ay kapag under the heat, under UV light, non-polar environment, or under a high energy source. At madalas po ito nangyayari sa radical halogenation and polymerization reactions. So now we're going to look at more examples. Next example is the bromine 2. It turns into 2 bromine radical. So similarly lang din po siya sa chlorine 2, pero mas onting energy lang po yung kailangan natin dito sa bromine 2. So, bromine molecules requires less energy to split than chlorine because bromine to bromine bond is weaker. So, next po, RO2OR. Then it turns into RO radical plus OR plus radical OR. So, ang tawag po natin sa RO2OR is peroxides. So, ang peroxides po are chemicals that breaks very easily under the heat, and when they undergo homolytic cleavage, nagpo-produce po siya ng alkoxy radicals. So, ito po, makikita po natin dito yung peroxides, and then yung results po niya, ang tawag po dun ay alkoxy radicals. So, last example po natin is nitrogen to nitrogen bond. So, nitrogen to nitrogen bonds also undergo homolysis quietly because their bond dislocation energy is low. So, it means it breaks easily and it needs very low energy. So, kung hindi pa rin po nila gets, think of it po na may dalawang taong naglalakad sa park. Tapos, tanghali po siya, so mainit po. Yung dalawa pong taong yon is magka-holding hands. So, syempre, mainit, may irritate yung isa, so, aalis siya. Aalis yung kamay niya. So, yun po yung homolytic cleavage or homolysis. So, naghiwalay po sila, then evenly pa rin sila. Kasi tao pa rin yung isa, tao pa rin yung isa. So, yun po yung example, another example ng homolysis. That's all po. Thank you.
So hi po, I'm Gail Rezen Favia, and I'm here to discuss the heterolytic cleavage. So the heterolytic cleavage is a process which is ang isang covalent bond ay maghihiwalay, pero yung electrons na nasa bond na yon ay mapupunta lamang sa isang atom at yung isa naman ay mawawalan. So para mas madali nating maintindihan, example, meron covalent bond sa atom A and atom B. Sa heterolytic cleavage, instead na tig-isa sila ng electrons, lahat ng electrons ay mapupunta kay atom B at si atom A naman yung mawawalan. So dahil doon, si atom B ang madadagdagan ng negatively charged ion, which is siya yung magiging anion. And si atom A naman yung mababawasan ng electrons, so siya yung magiging cation natin.
Hi everyone, I am Erica Marie de Maranan and I am here to discuss the examples of heterolytic cleavage. So heterolytic cleavage is the process wherein kapag nag-break yung isang bond, lahat ng electrons ay mapupunta dun sa atom ko na mas mataas yung electronegativity. So for example, yung yung hydrogen at saka yung bromine. Kapag nag-break sila, yung hydrogen, ang matitira lang sa kanya yung protons. Tapos, since bromine yung mas mataas yung electronegativity, dun mapupunta lahat ng electrons kapag nung nag-break sila. Next example is yung ethyl and chlorine. So, kapag nag-break sila, since mas mataas yung electronegativity ng chlorine, dun mapupunta lahat ng electrons. Since polar solvent yung reaction, doon nag-occur yung heterolytic cleavage dahil ang polar solvents ay nag-help na mag-stabilize ng mga napoproduce na ions.
Now that we are done discussing about the homolytic and heterolytic fission, we will now proceed to the nucleophile and electrophile. So let's first define the nucleophile. So a nucleophile can be split, so the root word can be split into nucleo, which means nucleus, and phile, which means loving. So it's loving for nucleus. So a nucleophile is an electron-rich reagent. So also according to the Lewis notion of acids and bases, it can also be called as Lewis base. So since a nucleophile is rich in electrons, it donates it and it accepts nucleons. Next is the electrophile. So again, it is derived from its root word electro and phile. So electro means electron and phile means loving. So it's loving for electron. So an electrophile is rich in nucleus. So it donates nucleus and accepts electrons. So it can only be positively charged or neutrally charged. And additional pala, a nucleophile can only be negatively charged or neutrally charged. So let's compare those two together. So a nucleophile, since it's already rich in electron, again, it donates electrons while it accepts protons. While the electrophile, since it's rich in protons, it donates protons and accepts electrons. So vice versa lang silang dalawa. So again, a nucleophile can either just be negatively charged or neutrally charged, while the electrophile can only be positively charged or neutrally charged. So these two so the nucleophile, it undergoes nucleophilic substitution and addition, while the electrophile, it undergoes electrophilic addition and substitution. Uh, that will be further discussed by the next group after us. So, dun yung mas better maintindihan yung dalawa. And lastly pala, nucleophile is also called as Lewis base, while the electrophile is also called as Lewis acid. So, mas maintindihan nyo pa yung nucleophile and electrophile pagdating sa discussion ng reagents. Okay.
Next we have is electrophilic reagent. So from its word electrophilic, electro from the word electrons and philic meaning loving. So nung meaning ng electrophilic ay electron loving na reagents. And also from its meaning na electron loving, wala silang electrons kaya naghahanap sila ng electron pairs para makabuo ng mga new bonds. So we have two types of electrophilic reagents. First is the neutral electrophiles. So from its name na neutral, meaning wala silang charge and kulang din sila sa electrons. And because wala nga silang electrons, naghahanap sila ng mga makukuha or ma-attract na electrons dahil electrophilic nga sila.
Okay, so let's proceed to nucleophilic reagent. So, a nucleophilic reagent is, they also called it as nucleophile, which is ang isang chemical species is nagtatanay ng electron pair sa isang electrophile para makaform ng chemical bond in a relation to a reaction. So, sa nucleophilic reagents, we have the two types. The first one is neutral nucleophilic, which is meron siyang lone pair of electron, or they called it as pi bond, and meron siyang same number of protons and electron para makapag-donate ng electron sa electrophile. But we have also a negative nucleophilic. Sa kanya naman is same na meron siyang proton and electron, pero ang pinagkaiba dito sa negative nucleophilic is ang mas madami ang electron ng negative nucleophilic, and or they call it as an ion.
So, next po is we have the amplifier. Sa amplifier po, it simply means po na isang molecule po is nagpo-possess ng characteristics ng electrophile and nucleophile. So, nakadepende po siya sa reaction conditions and partner molecule. So, dito po is we have the three examples, which is the H2O, water, the HCHO or formaldehyde, and the RCN, which is nitrile. So, itong tatlo pong example is, yun nga po, since amplifier sila, they possess both ng characters ng electrophile and nucleophile, and nakadepende po siya kung kailan po siya nagiging electrophile, nucleophile po, sa specific conditions. So, next po is we have the free radical. So, it is a radical po that is an atom, molecule, or ion that at least has one unpaired valence electron. So, nakalagay po dito na it is highly chemically reactive. So, bakit nga po ba siya reactive? So, it is reactive po because since nga po may mga unpaired valence electron po siya, nagsisik po siya makipag-pair or makipag-bond sa iba para po makapag-achieve ng stability, maging stable, or tinatawag po natin ng octet rule. So, here po, yung examples po natin is the hydroxyl radical, methyl radical, and chlorine radical. So, mapapansin niyo po sa example po natin na may dot. So, ang chemical notation po natin sa free radical ay dot. It is represented by a dot.
Good day everyone, my name is Christian Reyes Ascension and I will be discussing the delocalization of energy. So, start tayo, what is delocalization? Delocalization happens when the electrons are not stuck between two atoms. Instead, they are spread out over several atoms in the molecules. Usually, involved dito yung tinatawag nilang pi electrons. It is from the double bonds or lone pairs that can move through resonance. Because of the electrons are spread out, nagiging stable and much lower in energy yung molecule. So, bakit nangyayari yan? So, why the localization increase stability? So, when the electrons are shared across many atoms, the molecules avoid having a large amount of negative or positive charge in just one place. So, naiiwasan yung pagkakaroon ng positive and negative sides. Kasi, nakakalat yung electrons sa molecule evenly. And this reduces the repulsion and the balance electrons density, which makes the entire structure more stable. So it means that the more the localization is, the more stability the molecule will. Yes. So let's proceed to the main examples of the localization. We have here the benzene ring. The benzene ring is considered as the most stable or very stable. Kaya tinatawag natin siyang aromaticity. And the benzene, known as C6H6, has 6 pi electrons that are shared evenly around the ring. So all the carbon-carbon bond here in benzene are equally has equal length or distance, and it is between single and double bonds. The next one is the allyl cation, or known as CH2 double bond CH single bond CH2 with positively charged. So alam naman natin na yung cation is positive. Yes, cation, positively charged yun. So yung positive charge, it can move between the first and the third carbon kasi para silang CH2. And because of that, the charge is not trapped in one location. So kung hindi natatrap in one location yung charge, it means na stable yung molecule na yan. So the next one is the carboxylate ion, or the RCOO with negative charge. Yung negative charge can be shared by both oxygen atoms. And this gives two identical CO bond lengths. So makikita kasi natin dito na COO. So it means that it is a CO2 with negative charge. And dahil dalawa yung 2, it can be shared or it can be identically CO bond lengths. And dahil sa resonance, dahil sa paggalaw ng mga electrons, mas nagiging stable yung molecule na yan.
So, let's proceed naman po sa reaction intermediate. Ang reaction intermediate po ay yung middle guy sa isang reaction. Halimbawa, meron po tayong reactants. Sa reactants po yun, habang ginagawa po natin yung process na yun, hindi po natin agad-agad makikita yung product. Sa gitna po nun, gumagawa po ulit ng bagong bagay, which is yun yung intermediate. Ang intermediate po kasi hindi siya yung nasa una at hindi rin po siya yung sa tapos. Ginagawa lang po natin siya para po makatulong po tayo dun sa reactions para maging product siya. So sa madaling salita po, ang intermediate ay naiiwan lang po siya sa gitna at hindi po siya nakikita sa dulo ng product. Siya lang po ang tumutulong sa reactants natin para po makagawa po tayo ng product. So, next naman po natin ay ang electron displacement effect. Ang electron displacement effect po ay isang process which is yung electron ay gumagalaw po siya sa isang atom kapag may nakikipag-react po sa kanya. So, kailangan po natin yung process na ito para po makapag-start po tayo ng chemical reaction. So para mas madali po nating maintindihan, yung atom po meron po siyang nakakabit na electrons. Tapos kapag po meron pong nakipag-react po sa kanya, yung mga electrons na nakakabit po dun sa atom na yon is madi-displace. So meaning magmo-move po yung mga atom na yon sa iisang direction po.
So now we're in resonance and mesomeric effect under the electron displacement effect. So let's first define the resonance and mesomeric effect. So there are many organic molecules which cannot be represented by a single Lewis structure. In turn, they are assigned more than one structure called canonical forms or contributing of resonating structures. So the phenomenon exhibited by such compound is called resonance. So let's show up an example para mas maintindihan natin yung definition niya. Okay, so now let's give up an example of resonance. So para mas maintindihan natin siya, let's put up a quick recap. So we all know that in an atom, electrons move unpredictably inside of an atom, right? So the importance of resonance is that it helps us to determine that even if the structure or the position of an electron is altered in a chemical structure, the chemical components will remain the same. So let's put up an example para mas maintindihan natin siya. A good example of this is yung benzene ring. So we all know if we draw the benzene ring, we have total of 6 carbons, a cyclohexane, sorry, a 2,4,5 cyclo, I don't know, UPAC name na siguro. So and it have an alternating double bond. So I have 1, 3, 5, ayan, cyclohexane, UPAC name. So ganyan yung itsura ng benzene ring, right? So yung concept ng resonance or the idea of resonance is even if we move the electron from here to here as well as the other ones to the next carbon chain, the chemical components will remain the same. So if we draw the cucul structure, it will look like this. So right, and cucul. So that's basically resonance.
So we also have the electromeric effect. So it is the temporary effect where a pair of electrons from a double or triple bond is nagtatransfer sa isa sa mga atoms. Nangyayari lang to kapag nag-a-approach yung mga attacking reagents. So basically, nag-shift temporarily yung electrons para tumulong na mag-occur yung mga reactions.
So, moving on po tayo sa steric effects. So, steric effect refers to non-bonding interactions that affects the shape and reactivity of a molecules. So, nangyayari po to kapag yung electron clouds around the atoms repel each other when they get too close to each other. So, in simple terms po, when atoms or groups are crowded in a molecule, they push each other and repel, and this changes how the molecule behaves or reacts. So, moving on po sa steric hindrance. So, ang steric hindrance po is a result of the steric effects. It means that a chemical reaction becomes more slower or harder to occur because the atoms or groups around the reaction site is bulky or sobrang laki na po. So, yun po. Ang example ko po dito is like a blocking an entrance door. So, if large groups blocks the entrance door or surrounds the entrance door, other molecules cannot enter or come out the room. So, yun po. Hindi na po makakapasok ibang molecules sa isang atom kasi block po yung entrance niya. So, parang ganun po yung steric hindrances. So, in summary po, steric effects come from the repulsion caused by the crowded atoms, and steric hindrance is the slowing down of reactions due to the crowding. So, it's like creating a physical barrier at the molecules.
Good day everyone, I am Angela Macy Tafalia, and ngayon pag-usapan naman natin yung carbocation and carboanion. So first muna yung carbocation. Ano nga ba yung carbocation? Yung carbocation ay isang organic ion na merong carbon atom na may positive charge. So sa carbocation, meron silang 6 na valence electrons, which normally na meron silang 8. So may kulang sila, kaya nagiging electron deficient sila. Yung isang part na p orbital is walang laman, so nagiging Lewis acid or electrophile siya, electron acceptor. Ano ba ibig sabihin na electrophile? Ibig sabihin nun, electron loving sila. So, uma-attack sila ng electrons para mabuo yung valence electrons niya. So, kapag kulang siya sa electron, mabilis siyang mag-react. So, paano nga ba siya nabubuo? Nabubuo ito sa pamamagitan ng heterolytic bond cleavage, kung saan ang leaving group ay katulad ng halogen ay umaalis dala yung shared na pair electrons. So, paano nga ba siya nagiging stable? So, ang stability ng carbocations ay tumataas sa pagdami ng alkyl groups or yung mga carbon chains na nakakabit sa positive na carbon. Ito ay dahil sa inductive effect at hyperconjugation or electron donating effect ng alkyl group na tumutulong na mag-disperse ng positive charge. So, yung order niya is tertiary first muna, secondary to primary to methyl. So, sa summary or to sum up, pinagkaibahan nila sa charge, sa carbocation, positive sila, sa carboanion naman ay negative. Sa valence electron, sa carbocation naman, meron silang 6 na valence electrons, which is normally na may 8, so deficient sila sa electron. Kung sa carboanion naman, kompleto sila, so electron rich sila. So, ang ano naman nila sa role ng reaction, sa carbocation, electrophile or electron loving, electron acceptor. Sa carboanion naman, sila naman ay nucleophile, so electron donor sila. Tapos sa shape nila, sa carbocation ay trigonal planar, tsaka sa carboanion naman, trigonal pyramidal naman. Tapos stability naman sa pagsunod-sunod naman is baliktad lang sila. So sa carbocation mas nauuna yung tertiary, secondary, primary, tapos methyl. Tapos kabaliktad sa anion, nauuna yung methyl, primary, secondary, and tertiary.